So, I'm the person holding you back from lunch. What I'd like to do is cover 7 ineffective coding habits of many programmers. It's quite a long title, because I realized it needed clarification when I mentioned to my wife, about 7 ineffective habits of programmers. She sort of said, "Oh, I can give you a few." It's like, okay, that's years of being too close to the source. She said, "Yep, I've seen you. I've worked with programmers. I can give you a nice long list. 7, too short." I said, no. As she launched into the list, I said, "Coding habits," because she started talking about things like committing to times, deadlines, and stuff like that. It felt like a personal sort of character assassination. So there's that. The other thing is, I'm afraid I'm a real stickler for not using universals where many people use universals. When people use universals, they say things, "Oh, programmers do this," as if all programmers, as if there's a universal quantifier. For all programmers that exist, they all do this. No, they don't. People are kind of statistical and arbitrary in nature. So I had to put the many in there. So it gives us this rather long title. 7, I kept it at 7 because 7's a magic number. People really quite like it for whatever reason. It is the least random number between 1 and 10. If you ask a group of people for, think of a number between 1 and 10, it's most likely to be 7. Yeah, I think that's nearly 50% chance, so it's not 10%, which it should be, because we are arbitrary. And that's my excuse for the fact that we do have so many divergent conventions and habits. Habits are curious things. Habits are very helpful in many cases because they allow us to get on with stuff. You develop a habit, you don't have to think about it twice. You have a set of internalized habits for how you cross a road. Okay, you don't have, it's not a major cognitive task. You don't have to run through a list of things when you cross a road. Anybody who's got kids and has been teaching their kids how to cross the road will be familiar with these assumptions. All these other things, it's like these simple assumptions. My older boy these days, he asks me, because he's worked out it's quite cool to know a few things on a computer when he's doing stuff with his friends. So he's now discovered that shortcuts are quite a cool thing to know about. You don't want to just be mousy, pointy, draggy, clicky, droppy, all that kind of stuff. Yeah? So a few shortcuts. "Dad, what's the shortcut for this?" I have no idea. Give me a keyboard. Let me close my eyes. It's that. There we go. The habit. It's optimized away. A whole load of stuff. I don't have to think about it. But the problem is that occasionally your habits will backfire. You pick up a habit somewhere, and it's so ingrained into you, you don't even know you're doing it. And you've never even thought to question it in many occasions. Speaking of crossing the road, very simple one. The instinct, I approach a road, I look right, then I look left, then I look right again. That works perfectly well in this country. It turns out to be a not particularly successful habit in other parts of the world. Yeah? So therefore, there's a point that something that is so deeply ingrained. I actually, now, these days, actually, I just approach a road and I have no idea which way I'm going. It's just like, what country am I in again? So I become so confused. But I remember when I'd spent a few weeks traveling as a teenager, I came back home and crossed the Archway Road, which is a fairly busy road, let's put it that way. Crossed the Archway Road to go see my girlfriend. I'd just come back that day, and I thought, that's really interesting. There wasn't a lot of traffic on the Archway Road. I turned around, there's all these vehicles going past. I realised I'd been looking the wrong way. So, thanks to the gaps in the traffic, I'm still here today. Question your habits. You don't even know you've got them. And a lot of these things are very simple things about layout, naming, all kinds of stuff. You may have started with good motivation for picking up a habit or a convention, but sometimes it turns out it exaggerates and backfires over time. What's my interest in all this? Patterns. Patterns are capturing... The reason we're interested in patterns is ultimately because of successful behaviour. We'd like to repeat things that we know work. There's a whole load of stuff about people learning from failure, but actually what makes humans distinct from, say, chimpanzees in terms of learning behaviour is chimpanzees learn mostly by trial and error. Humans have this rather neat thing. We learn by following other people's successes. We imitate. Oh, that works. I quite like the look of that. We'll do that. Okay, that's one of the things that distinguishes us from a learning point of view. Distilled into another form, this is ultimately patterns. I got into patterns because I was very interested in this idea of trying to describe things. It turns out it's not just about AI design, it's about pretty much anything that is a deliberate, an intentional kind of practice. So that's kind of how I'm not going to present you with patterns per se, but that is certainly where I'm coming from, as well as the detail of the program. Now, something else that I do is, and I mentioned this in a talk yesterday, is I, as a hobby, because it's very difficult to earn a living as a writer. For those of you that are familiar with statistical distributions, it's worth pointing out that it's a power law. There's a J.K. Rowling over here, and then there's all the other writers out here. You don't really make a lot of money. But I write the odd short story here and there. I'm very, very focused on form and detail. And there was an observation made by Alan Holub at breakfast this morning. He said, good writing and good programming have a lot in common. Bad writing and bad programming probably also have a lot in common, but we're not going to focus on that. So that's where I'm coming in from, it's that kind of attention to detail and the like. And this is why we care. In JavaScript, the good parts, a surprisingly or unsurprisingly slim volume, depending on how you look at it, by Doug Crockford, he notes, it turns out that style matters in programming for the same reason it matters in writing. It makes for better reading. So let's start off. You may have remembered that the world was supposed to end a few years ago, and then again a few months later, and then again December 2012, then 2 months ago, February. Remember, it's supposed to be Ragnarok? Yeah, it's the doom of the gods, and it didn't happen. What I'm interested in here is getting lost in the crowd, noisy code. This is a habit we don't realize we're doing. We create noise. What do we mean by noise? Well, let's talk about signal-to-noise ratio. In its formal sense, we understand that signal-to-noise ratio, we talk about it in terms of transmissions. It has a formal meaning. A measure used in science and engineering comparing the level of a desired signal to the level of background noise. But we also use it culturally to refer to the ratio of useful information to false or irrelevant data in a conversation or exchange. So let's take a nice little example, reasonably famous. Apparently, what did I hear? Benedict Cumberbatch is going to be starring in Hamlet, which should be rather interesting. To be or not to be, that is the question. Okay, this is pretty well known. Less well known, and this is good. It's got power, it's got brevity, it's got appropriate balance, use of the words, great stuff. In his book, Long Words Bother Me, a lovely book by a guy called Tom Burton on language. He's a scholar of Middle English, but he wrote this book on the English language and various bits and pieces, and he had a bit of fun with this one. So he thought he would turn Hamlet's existential question into his existential ponderings into business speak. I've got to say, I see a lot of code like this. You know, you could say it directly, or continuing existence or cessation of existence. Those are the scenarios. Is it more empowering mentally to work towards what? So what are we talking about here? So there's an example I tend to use. I use it in training courses. I use it as a teaching example. Funnily enough, I've even actually used it in client code, although a somewhat more optimized version. Recently used list. People often use stacks. Stacks are boring. Recently used list, like your recently dialed numbers on your phone, your recently opened files. Okay, so this is a data structure that has stack-like properties. The most recent thing goes to the head. But it also has set-like properties. When you add a thing that's already in there, you don't get two of them. Okay? When you reopen a file that's already in your recently open files list, it doesn't insert it twice, it moves it. So it's got a little more interesting behavior. So it's a bit like a set, a bit like a stack. So this is based on some code in a training course that I ran, test room development C#, and a pair of developers came up with this, and they said, well, we've got it passing the test, but we're really not sure about it. We think it might be too long. And I said, yes, it might be. Now, at first sight, this looks half the length. Okay? Let's count that again. Let's actually count. There's a distinction there's a distinction in language, distinction between a function word and a content word. A content word is a thing like dog. It denotes something. Dog or run or something like that. A function word is a thing like to or the or a. It's just a filler word that is there for the grammar, and it clearly has use, but it doesn't actually refer to anything substantial. It's an artifact of the grammar. If we differentiate content from function, so to speak, we'll actually see that most of this is content. Okay, we actually have a lot of statements going on. There are things happening. There are decisions being made. There are things being looked up and various things being looped here. Over here, we don't see much of that at all. There's actually 5 lines where something actually happens. All the rest is just decoration. Content is in the minority here. It's overwhelmed by the syntax. Now, that's not simply a case of just reducing this. You'll notice there's no control flow on the right. There's control flow on the left. If you imagine a code base written in the style on the left versus a code base written in the style on the right, there is a fundamental difference. I think this is sometimes why people fail to appreciate the significance of certain small examples. The point here is that which code base, if I said, now imagine a few thousand lines written in the style on the left versus a few thousand lines written in the style on the right, you suddenly see the complexity mounting up. The one on the left becomes an obstacle. Of course, it does the same thing. It is actually, although actually, no, there's another feature to the one on the left, it's slower. So the point here is that we accumulate the noise without really meaning to. The noise accumulates at the smallest level. People don't set out to write large classes. There's no, I'm fairly sure they don't, there's no ambition. You don't sit down and say, you know what, I'm going to write a really long class. I'm going to just have some, I'm going to throw away cohesion. I'm just going to have as many dependencies as possible, and I'm never going to touch the extract method refactoring. I'm just going to create big old fat methods. And I'm really going to go to town on this one, and I'm going to make this an absolute nightmare for anyone, myself included, that touches this. And that is my ambition for the day, and that's the first item on your to-do list. I'm going to take a wild guess that that doesn't actually happen. What happens is the gradual accumulation. It's a very gradual accumulation. That's what causes that one on the left. That was produced in a lab that lasted 60 to 90 minutes. Okay? The emphasis of the lab was on testing rather than this code. But nonetheless, in that period of time, you had 2 people trying to figure out the nature of the problem, and within 60 or so minutes, they had produced the thing on the left. And that's just like real work. In a few hours, you produce something, and there it is. And you don't go back and touch it. But that's okay, because it's only short, it's only little. And then you do the same thing again, and then you do the same thing again. Once you start repeating that, that becomes the architecture. There are also some other outstanding habits that people have, some astonishing ones. Occasionally, people say, what language feature would you like to not have? For me, it's a bit of it's a close-run thing. If somebody said remove something from a programming language, and let's just pick, the curly bracket family. If somebody said remove something from it, it's a close-run thing between the continue keyword and comments. Okay? It depends on the day and depends on how I'm feeling and if I've seen any continue statements. Continue is a kind of a profound dysfunction in control flow. Whenever I see it, my heart sinks. You just know the programmer had no idea what they were doing and they were panicking. I need to get out of here and go round again. I'm lost in a maze. I have no idea where I'm going. Look, continue. And it defeats simple refactorings as well. It's just a clear panic reaction. But then again, I see comments every now and then that make me think the same thing. Somebody's following some very careful ritual here. The somebody in this case is Oracle. Let's remove the noise. Oh, there we go. Hello world. Look at that. Just to be clear, you don't want to be running this in any nuclear power stations. And they're not responsible for anything that goes wrong. It's even called Hello World app, which I think is glorious. But of all the things, all of that, and you know what? They still get it wrong. There's a comma missing. Yeah, it's different. Yeah, hello world. You put a comma in there. It's the old one. Punctuation saves lives. Let's eat grandma versus let's eat grandma. Yeah? Punctuation, it matters. It saves lives, and it stops you looking like a fool when you publish code like this. Look at all of that. I mean, really, does anybody read the right statements? Has anybody actually sat down and read them? Yeah? There was one that I was copying and pasting in a code base a few years ago because it's the ritual that was necessary for the code base. When was that? 2004? I went back to that code base in 2009, 2010. I actually read the copyright message. Quite a lot of errors, spelling, grammar, it's just like, it's worthless, absolutely worthless. So why does that matter? It's not just the copyright message, because that engenders a particular mindset when you go into the code. So this is fairly classic advice. I never tire of retelling this one. Very influential book, Elements of Programming Style. First edition came out in 1974, second edition 1978, 79. I've never found the first edition, but I did lay my hands on the second edition. The book is written in two dead languages, Fortran 5 and PL1, but the advice is timeless and way ahead of its time. If a program is incorrect, it matters little what the documentation says. By documentation, they're referring to comments. If documentation does not agree with the code, it is not worth much. Yeah. And this is important because we always need to remember, whenever you write something, there is an audience. Who is the audience? There are two audiences that matter. Yourself and the extension of yourself, other programs, and the compiler. So basically, humans and machines, that's it. Who are you writing comments for? Well, it's not for the compiler, so it must be for somebody else. It must be for another person. Perhaps yourself, perhaps a colleague, perhaps somebody you've never met before. And do remember that you in 6 months' time are somebody you've never met before. So time travel, basically, communicating with the future. That all sounds very laudable. It sounds like a really good idea. The problem is that most of our advice stops there. Yeah, write comments, comment your code. Not very helpful. What happens when there's a bug in the code? Well, when there's a bug in the code, one hopes, ultimately it gets fixed. There is a call to arms. We will log this as a bug. How many people actually log defects in their comments? Yeah. How often does that actually happen? It never happens. But they just sit there because it turns out that ultimately the machine is the one that determines the meaning of truth. And so therefore, if there is a bug, we fix it. If there's a mistake in the comments, we leave it. And we leave it, and we leave it. Sometimes we know it's there. Most often we don't. We never realize it. It's normally only when somebody new joins the team that they make that foolish newbie error of reading the comments. You have a little laugh and you say, oh, don't read the comments. Nobody reads those. I had that with a team once where I said, after spending a day looking through the code base, I said, you know what, the single thing that you could do to improve the quality of this code base would be to remove all of the comments. As it happens, I have a script here for that. And they said, oh, well, no, we might, we don't want to do that. I said, why not? Well, you never know, you might find them useful. I said, I've just looked at them. Trust me, they're not useful. They had me heading in that direction when I should have been going in that direction. And they said, oh, well, in which case it doesn't matter, because we never read them anyway. It's like, well, wait a minute, you just told me that you weren't going to delete them because they might be useful, but now you said you're defending them because you don't read them. That doesn't make any sense. People are irrational. We hold on to things for arbitrary reasons. And comments, I don't want to let those go. They might be useful. Tell you what, I'll do you a deal. I've got something far better than your memory. It's called a version control system. Yeah? Yeah, there it is. It will remember this stuff for you. It will remember it for you wholesale, no problems. And you can go ahead and delete them if they're causing a problem. Because the code must largely document itself. If it cannot, rewrite the code rather than increase supplementary documentation. The most important sentence here is good code needs fewer comments than bad code does. We're not saying don't comment. What we're saying is, given the choice between apologizing for the code, which is often what we do, little comment, it should be like this, and that variable called A is the height indicator, obviously. A is for altitude. Yeah? Flag 2 is the second flag we thought of after flag 1. Yes, I have worked in a code base with variables called flag 1 and flag 2. Those are the meaningfully named ones. And so the point here is, don't apologize for the code. What modification in the code will allow you to get rid of the need for a comment? In most cases, you can find something that the comment is compensating for. Change the balance in that case. Comment should provide additional information. If you're parroting the code, then all you're doing is simply repeating what the code already says. You must assume that the reader of the code is equipped to read the code. Otherwise, there's no amount of commenting that will help them. Actually, that's not true. And this goes back to this question of, what should I comment? A friend of mine, many years ago, we were both at university together, we both got programming jobs afterwards, and he had this lovely tale of some development that a colleague of his had been asked to do. And this guy was new, and he was going to write some Object Pascal, and this keen programmer asked the boss, how should I comment my code? Because he wants to try and do the right thing, you know. And the boss said, oh, you know, so anyone can understand it. Now, this is the problem. You've got to be careful with programmers, because they have amazing attention to detail, and they will deconstruct your sentences in ways that you had not previously considered. The resulting code base, resulting program, was very thoroughly commented, to the point that if you did not know Object Pascal when you started reading it, you would by the end. It included a complete primer. Every time a new language feature was introduced, it introduced what it meant. And there was a big tutorial in there, because the guy had said, so anyone can read it. Yeah, you've got to be careful with those universals, okay? And this is the point. We need to have a proper philosophy. If you are, I mean, one of the most ridiculous ones was a company that I ran some workshops for, you know, full week-long workshops with reasonably realistic development within the week in teams. And I remember looking at one guy's, looking over the source code, one guy, and I said, you've got this huge, great banner comment at the beginning. Yeah, that's the company style. We have to do that. I said, what do you mean you have to do that? He said, well, actually what we have to do is that our code is checked, so that 10% of the code must be, 10% of the code lines must be comment lines. Never, ever give numeric targets like that to programmers. Programmers are smart people. Programmers invented the internet. The internet was designed to root around damage. It turns out that's what programmers do as well. You give them a stupid metric, they'll find out ingenious ways of rooting around it. Yeah, sometimes intentionally, but because they're smart, sometimes it's unintentional and subconscious. Yeah, if you tell me 10% of those lines need to be comment lines, I've got that one covered. I will what I will do is I will come up with the most elaborate copyright message possible, and I will put it at the end of every file, where it's out of the way and doesn't harm, you know, children, programmers, and other businesses. Okay? Just keep it out of the way. But these guys, they had this massive, big style banner comments and stuff like that, including, above every single method, the observation that this method was in C#. Just in case you hadn't figured it out by this point. In case the .cs suffix had not clued you in, the fact that it was a .NET project, and that the fact that the syntax looked horrifically and amazingly just like C#. Yeah, people are not that stupid. I've even started teaching my 12-year-old, who only knows a bit of Python. I've even started teaching him how to recognize languages at a distance. Just as you can listen to somebody on the underground, and it's just like, oh, okay, that's a member of the Romance family, or it's a Slight family. Oh, not sure what that is. That sounds like it's possibly somewhere, and you can start localizing things. You look for certain cues. You can do it with that. Somebody who's actually paid to develop code will have no problem at all saying that's C#. A comment telling you it's C# does not add to the wealth of human knowledge. Mnemonic variable names and labels and a layout that emphasizes logical structure help make a program self-documenting. I will come to logical structure and layout in a moment. But there is a point here. People often use that. We need to temper this a little bit. Sometimes people say, oh, okay, well, my programming style is self-documenting. A lot of people think that. Most of them are wrong. The self that determines whether or not your code is self-documenting is not the self that wrote it. You need another pair of eyes. You need somebody else to determine whether or not it's clear. Now, when I started learning C, which was in the dim and distant past, I was handed a printout of this Notes on Programming in C by Rob Pike, which was written Turns out just before I started learning the stuff. And he made this observation. Comments. A delicate matter requiring taste and judgment. I tend to err on the side of eliminating comments for several reasons. First, if the code is clear and uses good type names and variable names, it should explain itself. Yeah, so what we're doing here is we are re-emphasizing communicate. The purpose of the code is to communicate. Your choice of identifiers is an act of communication. It's not just arbitrary. You are trying to communicate a concept. Software development deals with many, many abstractions. You want to try and make them as concrete in the mind of the reader as possible. Names are the only tool that you have for this. Okay. Second, comments aren't checked by the compiler. There's no guarantee they're right, especially after the code is modified. It's rather good that there is a slow but sure increasing trend, at least on spell checkers. More and more people are finding that it pays to have their code actually checked at this level. But there are deeper issues. You'll never check the semantics unless you really know what's going on. But a misleading comment can be very confusing. Third, the issue of typography. Comments clutter code. Noise. Noise. We must be very, very careful with that. Now, the thing that I really wanted to refer to in this article, this paper, this is one of my favourite ones. It's a famously bad comment style. I equals I plus 1. Comment, add 1 to I. And there are worse ways to do it. Beautiful, glorious, formatted banner. Don't laugh now. Wait until you see it in real life. Did I take Rob Pike's advice when I read this? Of course I didn't. I laughed at the example as I read it. I laughed now. Then in the mid-90s, a few years later, I did a contract working at a bank in the city. And I saw this. The bank went bust 6 months later. Cause effect? No. But it was one of those things. You're looking at it going like, did somebody really actually spend time doing this? You know, it's, again, human knowledge. It's not just about the cats. Okay, so this is something I tweeted a while back, and this has kind of been tweeted a couple of thousand times, retweeted a couple of thousand times. Common fallacy is to assume authors of incomprehensible code will somehow be able to express themselves lucidly and clearly in comments. This is actually a fallacy. It took me years to realize. People say, well, write the code and then explain it to the reader, because they might not be able to understand your code. Okay, let's do a little bit of root cause analysis here. Why might they not be able to understand the code? They might not be able to understand the code because it's not clear. In other words, it's going to be written, it doesn't clearly express itself. It doesn't use the right terminology. It's not organized in a way that allows you to understand it. It's not clearly explained. It's not self-explaining. It's not structured in a way that allows other people to understand it as an act of communication. And the same person that wrote that code is now going to write more stuff that tries to explain the thing that they just failed to explain. That doesn't sound good. Now, that's not to say that, as I said, not all programmers suffer this, but there is this kind of logical fallacy that the person that cannot express themselves in code will somehow pull a rabbit out of a hat and be perfectly lucid when they come to write it in words. There are occasionally people that do that. I have worked with one. Absolutely astonishing. I remember he gave me the most profound and insightful descriptions of the code, or rather what the architecture was doing and how the code worked. And he described it, and I had visions of this beautiful code base. And it was really, really clear. It turns out the code was very efficient. It did everything that it was required of it. But when I looked at the code base, I found this massive disconnect. I remember thinking, how can this code have been written by somebody who gave such a clear explanation? Had he not told me what he'd told me, I wouldn't have seen it in the code. Yeah, it felt like I was cracking a puzzle. Okay, so I said I was going to talk about spacing, formatting, things like that, because one of the things we need to be aware of, I said that the main act of communication, the primary semantics of our code, is expressed in names. Turns out there are two other tools that we have in programming languages. Names, spacing, and identifiers. That's it. That's how you communicate. The organization of space and punctuation is mostly checked by the compiler, so we don't really need to worry about that the same way. But spacing, yes, if you're wondering, I am going to talk about that untalkable subject, that elephant in the room, that thing that you are never supposed to discuss because it's subjective and personal, I'm going to talk about indentation. But I will do so in a way that is rational, which means it'll probably piss off a few people, because it doesn't necessarily agree with your personal practice. I will say up front that in this space I have managed to try every style and make every mistake in the book, so I'm quite comfortable that there's something here that might be right. Now, I'm not going to tell you how to do it. What I'm going to do is I'm going to make observations about the way in which we don't do it effectively, or the properties of the spacing in the code. Whenever you do something, it serves a purpose. What purpose does spacing serve? You know, it's not just an arbitrary thing. What purpose does it serve? It has a reason for being there, therefore it is a designed thing. It is like a door handle, and you can tell whether or not a door handle works. You can tell whether or not a shower tap works just by trying to use it, once you have defined its purpose. So what we can do is we can define, rather than a style of spacing, we can define a set of properties that we would like from any style. In other words, a set of, guess what, requirements. If it's a designed thing, we can approach it from the perspective of requirements. So, back to Shakespeare, back to business Shakespeare. How do most programmers lay this out? Oh, something like that. How do people actually approach this stuff? How do people actually write stuff? They've got a space in front of them. How do they choose to fill that space? Well, they tend to think of it like this. So many programs, they think that what they've got is a lot of horizontal space. And maybe this is some kind of appeal to the fact that, it goes back to, primitive humans hunting across the plain, looking across the horizon, the vast horizon there, for signs of lunch that they can chase down. There's a problem with this. We don't naturally do that. That's why you've got your eyes on swivelly things, yeah? And actually, we don't tend to move them that much either. We have a very narrow band of focus. And although we technically have peripheral vision out about here, what you see is right in front of you. A lot of programmers program this way with the idea that it's okay because I've got a big screen. Yeah, and I've got a big neck ache just looking at your code. I remember pointing this one out, so saying, guys, column 120 is not great, and column 160 is really out. And programmers looked at each other. So you're saying that column 250 is really bad? Yes. 250, I mean, that's practically, I shouldn't need an iMac screen to look at your code. So, what's that line? Oh, that's the 80-column line. Oh, but we don't need to do 80 columns. Yes, you do. Actually, I could be really hard line about this and tell you what people actually look at. It turns out that we normally read to about 60 columns. That's what we're good for. I suggest, it turns out that I'm not saying this arbitrarily, there's an empirical basis for this. What is that empirical basis? Go to a bookshop. They still exist. They're not just there to figure out what you want to order from Amazon. Go to a bookshop. I went to a bookshop earlier this week with my wife. It was disastrous. We went in wanting to buy some books, and it was a complete failure of a mission. We came out with twice as many books. That's why I love bookshops. And a conversation about the books with the guy in the shop. Books are not formatted in the way that most developers format their code. Books are not formatted not so much in landscape as kind of like Serengeti. Let's call it Serengeti, yeah? Wide landscape. Because that's not how people read. People simply don't read like that. People read, I'll stick to English on this one, left to right, top to bottom, in a way that doesn't involve you moving your head. And it turns out around column 60 is your limit. Go and look at some websites. Go and look at the sites and how web designers lay out the content. You don't tend to find things stretching from left to right bar. There is a reason for this. Those sites are the ones that people need either extra patience to go work with because there's something there they really want to read, or they're ones that people are going to just click away from very quickly. Code, the property of code is that you want to be able to read it using the fact that people know how to read and taking advantage of the skills that they have. It turns out that the left-right thing, that's too much. So I still, basically I try to get, if I hit column 100, I know I'm doing something horribly wrong. I try to make sure everything is under 80, but I don't always succeed. Simplest way of checking whether or not something is, so basically I regard 100 as a hard limit, 80 as a kind of bump in the road, speed. I want to keep everything within that. And it turns out there is a very simple way of enforcing this. I mentioned this on Twitter the other day, and there are a number of suggestions, because the suggestion that I have, and where I really noticed it, the guys who had the 250 column code, before we even hit that, the conversation had already started because we were doing a group code review. Projectors. Projectors lag behind whatever resolution you have on your screen. If you've got a double-headed workstation and you've got full HD on both monitors, it's quite likely the projector in your meeting room is still probably running on 1280. And in some cases, heaven forbid, I've even found 1024. Yeah? So that's the first thing you do. You run it on a less brilliant device. And that was the point. That was exactly what had happened in this particular meeting. We were looking through the code, and it turns out there were two statements right next to each other. And they were identical up until the right-hand side of the screen. And the guy said, oh, but yeah, they aren't the same. The difference is, and he pointed somewhere off into the wall. And he said, but it looked fine on my machine. You know that's a quote that we hear every now and then when people mock the fact that you haven't tested something properly. It worked on my machine. The same goes for code layout. It worked on my machine, whatever. Can I read it on an iPad? Can I read it on my phone? Try different devices. Respect the reader. It's a designed thing. Now, there are interesting questions. Why is this stuff probing the right-hand side so much? We'll come back to that in a moment. Let's talk about this idea of visual design and space layout. It's a rather nice piece by Daniel Higginbottom, Clean Up Your Mess, a guide to visual data design for everyone. To answer the question, what is clean design? Most succinctly, a clean design is one that supports visual thinking. Now, this is important because we also use the term clean code and clean design in the context of code. But specifically here, we're talking about a different kind of design, visual design. It supports visual thinking, so people can meet their informational needs with a minimum of conscious effort. That's what we want. That's what we mean by a good design. It's almost invisible. It's unsurprising. You convey information by the way you arrange design elements in relation to each other. This information is understood immediately. If not, then, importantly, this is great if the visual relationships are obvious and accurate, but if they're not, your audience is going to get confused. They'll have to examine your work carefully, going back and forth between different parts to make sure they understood. Occasionally you get the philosophy, well, it was difficult to write, it should be difficult to read. That's not one that I tend to be a fan of. And the idea, well, yes, my work is so brilliant, it does deserve careful attention. Well, maybe it deserves a different kind of attention. So let's talk about some specific habits. How not to lay out a method header. I see this one so often. I'm not going to put any percentages on it because I know it varies from company to company and programming language culture to programming language culture. I find that it's probably more common in Java than it is in C#, a bit more common in C# and C++, and certainly a lot more than I find in something like C. When it comes to dynamically typed languages, actually this issue doesn't occur quite as much. So what's wrong with this? It's a really common style. Well, you can see what's wrong with it by asking the question, can you point to the argument list? Yes, with two hands. There's the argument list. It's in two places. But I just said the argument list. Surely the argument list is one idea. It's a thing. Well, apparently it isn't. It's on the right-hand side and on the left-hand side. It gets more exciting when the right-hand side and left-hand side are even further apart than you get on a PowerPoint slide. And even more exciting when the right-hand side is off the screen. Oh yeah, that two-argument method. What two-argument method? I seem to be having trouble calling it. There's a three-argument overload. No, that is the two-argument method. What? Oh, there's the other argument hiding over here, out towards the sunset. Yeah? This is just sloppy, okay? This happens a lot, though. So, no. Now, there are effectively two ways. I'm not going to favour one or the other for laying this out. And if you can get it on the line at the end, then that's fine, but I'm talking about where it is too long to do that. As I said, what we want to support is properties of something. What are the properties? The properties I want is that an argument list is an argument list. It is a thing. And visually, it is a thing. It's a single unit. And it should have one reading order. It should be either top to bottom or left to right. I should not involve scanning and doing a search across the page for bits of argument list. And ideally, you want to avoid anything that mixes the top to bottom, left to right approach. So I'm not favouring one or the other. I'm just saying this is the property you want. An argument list should look like an argument list. But there is a very common style that people use, again, that still supports this but has problems. This one. This is very common. Lining it up with the open parenthesis. Now that seems to satisfy my requirement that I want the argument list to be a single visual entity. I don't want to have to scan to find it. I don't want the surprise that it's off the right-hand side. Truncation where I'm not expecting it. I don't need that idea. Just think about it. Go and look at a movie poster and see how they lay out the movie poster. Go and look at a web page, a newspaper, or anything like that. See how they lay the stuff out. You'll see that they don't do it like this. But this one looks appealing, but there's a reason not to do it. It's similar to the calling convention people use here. Declare a variable, initialize it, and we'll initialize it, and we will align the arguments like that. Now, in many cases, what we're actually finding out is that there is perhaps a deeper problem here. Perhaps our identifiers are too long. We'll come back to that one later. But there is a problem with this one. Here are a couple of ways. There are actually other ways. Again, I'm not going to favour one approach or another. I'm going to tell you what the property is. You want to format that thing up there like this, or like this. As an aside, you will notice that everything that I've recommended incidentally pulls it back from the right-hand edge. That wasn't my original motivation. It's just that I noticed that when you relay out code according to visual design, you don't end up stamping over the right-hand side. But there's a more fundamental property. The far more fundamental property here is to do with layout, or to be precise, what's one of the most common things that happens to code? Change. What kind of change? Oh, change like, I don't know, renaming. You see, I don't actually see the top example that often. What I see most in code is that one. A disalignment. In other words, although the original author has decided to aesthetically lay out their code, what they've done is they've created it's what we call an unsustainable style. Because it's a high maintenance style. That means whenever I change the name, I have to go around and check. In fact, I did have one person who clearly, as I said, this stuff is often very personal. One person came up to me after a session, it was at a company, he said, you know, I disagree with what you're saying. That's fine. You know, I always make sure that whenever I refactor, I go around and I check that everything's lined up, and if it's not, I then line it up. Which I did point out to him roundly defeats the idea of an automated refactoring. Yeah. In other words, the whole point is refactor, you know, fire and forget, just refactor, and I know the code won't be messed up. And I said, do your colleagues do this as well? And he said, no, it's really infuriating. Okay. It turns out that you can either educate your colleagues in the ways of spacing, or you can go and fight other battles. Choose a style that is low maintenance. What we see here is that you can rename it and it will still be correct. The things that were lined up were still lined up. Amazing. So, yeah, don't do that. It just doesn't work. And it's the same for the right-hand side. The other characteristic, which I haven't gone into, is most noticeable when you scroll through code. And we'll look into it in a moment. But when you scroll through code, if you line up with the opening parenthesis of a call list, when you go through a file, your code looks random. It looks arbitrary. It looks messy because where that alignment falls is utterly arbitrary. It's not dependent on the logical indentation that you're using elsewhere. So as you scroll through it, the lines of focus keep bouncing around. They're utterly random. It actually, so in other words, the overall sense is not of a programmer who's taken care, but a programmer who is indecisive, which is not the approach that you want to give, because you probably weren't when you wrote it. So let's look a little bit more at that. So this is some Java code-ish. I mean, it's obviously dummy names and stuff like that, and I left off the return statement. This is fairly common in particularly in the Java world, when I see elements of this style creeping in elsewhere. First of all, we have this alignment there. Now, so there's a lot of interesting stuff. First of all, the idea that it goes off the right-hand side. That's normal, so I want to represent that here. So there's our line, there's a line of alignment. When you look at something, there are centers and lines of things that attract your attention and your focus that you scan along. That's why lines and things like that are used in design. They attract your attention and they direct your attention. So that's the line of alignment that we're introducing. But it's not the only line of alignment. There's another line of alignment here with the method call, and another line of alignment here with the method call within the condition. That's 3 lines of alignment. But actually there's more lines of alignment, because actually there's that one, and that one as well, because those are logical indentation. So what we have in the space of just over 8 lines of code is 6 visual lines of alignment. These are all things that your eye has been told are significant. That's quite a lot. That's quite a high density. What's it going to be like in a production method? It's going to be significantly longer. So the first thing to do is choose the sustainable style of spacing. Now, there's other things we could do with the condition. I'm going to leave that to one side, as well as the logic of using uppercase letters for constants, which has to be one of the most brain-damaged practices I've ever seen. I'm astonished that Java did it. I'm still astonished that people still do it. Some languages have shaken that one off, but I'm not going to cover that one today. Now, this all looks good, because we have basically 3 lines of alignment, but we have another problem. Yes, you're right. I'm going to talk about that other holy of holies, the thing you're not supposed to talk about, where you put your curly braces. It turns out that there is actually an objective and rational way of determining this. Having used every single curly brace placement style under the sun, I'm quite happy to say I've tried them all. There is also the other unask the question approach, use Python. So, you know, I haven't had to teach my kids anything about curly bracket alignment, but there's a problem here. Because if I look down the left-hand side, I see 4 declarations, but it turns out that only 3 of those are in the argument list. It turns out that this is one of the reasons that a lot of Java programmers do this, because they recognize this is unreadable. This is also the reason that a lot of people push stuff out to the right-hand side, because they feel they're forced into the alignment, and in other words, one thing leads to another. And most of it actually is rooted in the fact they put the curly brackets in what I can now definitively describe as the wrong place. If you don't do that, you don't do any of the other things. Well, within reason. You may still do them, but the point is that these are forcing. They're naturally forcing you. If I put the curly bracket there, then that looks unreadable, and this looks better, even though it has multiple points of alignment, because at least I've got visual separation. The problem is that there's no visual separation here. If you look here, and I just replace everything that's not punctuation, there's a big block down the left-hand side. There's no visual separation. If I introduce curly over there, there's visual separation. Boom. That's the point. So this is clearly dependent on a number of factors, but what I'm saying is, let go. I still occasionally present Java code using the curly bracket in the kind of conventional Java location, because it depends how much I want to freak people out in one go. I think only one freaking out at a time is good. But it turns out there is a rational way of looking at this, and it is to do with visual separation. So what we're talking about here is that your layout needs to meet some very basic requirements. Whatever indentation and arrangement style and alignment style that you choose should be sustainable. Basically, and I'm going to make a difference, sometimes a difference. Indentation is the logical thing, and alignment is the purely visual thing. Most people get indentation right. It's the alignment of other elements that becomes the issue. So what I'm saying here is, it turns out that alignment is a visual design thing, and that's it. So you can actually judge it on that. So is it, does it make sense? Does it give me the properties that I want when I look at the code? Does it force me into other habits? Does it have downsides? Is it readable? Is it sustainable? These are objective properties, it turns out. And there are many styles that satisfy them, and there are many that are not. And those are, that's the point, you have to kind of let go of this one a bit. Now, let's talk about this question. Why is it that there's another reason things push out to the right? It's not just to do with the issues of spacing I've described so far. The other reason is what I refer to as Lego naming. We all know about Lego, the greatest toys ever invented. You just take one thing, you put another thing, put them together, oh, brilliant, and you can just keep on adding things. It's great. There is indeed, in languages, there is a process known as agglutination. Agglutination is a process in linguistic morphology, derivation in which complex words are formed by stringing together morphemes, each with a single grammatical or semantic meaning. Okay, so you have a number of languages that are strongly agglutinative. Turkish, for example, is strongly agglutinative. German is quite agglutinative. English less so, but it does have a certain amount of agglutination. And you end up with some glorious things like this, which is technically the longest word in the English language, although ironically it's based on Greek and Latin. And it's basically a pulmonary infection based on particles that you might get through breathing in sand, dust, or volcanic ash. It's a completely made-up word designed to be the longest word in the English language, which is why it's not very often used. But a word that is used in Norway is this one. I will leave you to read that one. But of course, Norwegians aren't going to take the prize for this one. No, it's got to be German. That word was retired last year because the meatpacking directive to which it refers has been retired, so the word has been retired. There is an abbreviation of this, and apparently it's 9 letters long. I'm not even going to... I can read a bit of Norwegian and German, but I'm not even going to attempt to pronounce those. I can't even pronounce the English one. So what do we end up with? What's the problem with our coding? Our coding problem is that we end up with these gluey names, with these Lego-style naming. Oh, I'll take this word, and I'll glue it to this word. I will... Yeah, you can actually go and look at this. Method namer and class namer. Classnamer.com is an interesting one. If you struggle to find a good name for your classes, just go to classnamer.com. It does all these concatenations for you. Jeff Foster wrote Method Namer based on this one. And, there are lots of standard parts that people put in, proxy validate service. I mean, there's all of these various things. So do you have if you've got a service manager, then you probably need a service manager controller, and there should probably somewhere be a service manager controller manager factory. And you don't want to refer to the factory directly. Oh no, that would be rude. Use a proxy instead. So there's a service manager, controller manager, factory proxy. And we just take these standard parts and we say, oh, we're being meaningful. I'm not using abbreviations. Well, that's true, that's good. We've kind of, most people have got out of the habit of using certain abbreviations. We're not using abbreviations, no, but actually, by adding more words, are we adding more meaning or are we actually diluting it? This is kind of almost homeopathic naming. I'll just add more and more, and actually the effect becomes more and more dilute. I'm using lots of words, so I must be using meaning. No, it turns out that doesn't always work. So I'm going to and before you start thinking, oh, it's always about long names where you concatenate them, actually, I'm going to choose a really simple example. This came out of a recent consultancy visit. These habits, as I said before, sometimes these things start with the very small. People often think, oh, it's with the really long names that you get the problem. And then you add more bits to them and they become longer. No, it all begins with the very simple stuff. So I was going through this code, we were talking through this code. It's like condition checker. Check condition. These are noise words. So I said before, writing, I tend to focus on it, and one of the form of writing that I write is called flash fiction, which is really short fiction, where the word count matters. You learn to spot noise words and cut them out really quickly. And you can see the same in code. When you start seeing checkers everywhere, unless you're playing it, then unless it's a program about playing drafts, then it's probably not the word you want to have all over the code base. Condition checker, check condition. Oh, that's what we meant. That object, an object that implements that interface is a condition. And when you ask it whether or not it's true, you're asking whether or not it's true. We have this kind of object-oriented assembler style, where it's kind of like we feel like we're kind of, oh, get this, set that, like we're directing the objects around. I want you to check this. It's like micromanagement, sort of managerialism rather than object orientation. Hey, you're a condition, as opposed to a condition checker, or a condition checker object implementing an interface called condition checker, which wouldn't surprise me to see one day. The point is, what do you represent? A condition. That's it. Checker? No, that you are the condition. But how do I check? Well, are you true or false? Well, you just asked me. I don't say check condition. Just like, are you true? That's it. Simple. Done. So even at the small level, we find that there's verbosity. So Java example, I'm not going to talk about the intelligence or otherwise of using checked exceptions in Java. It's mostly the otherwise. Always the otherwise. But I'm using it here because of the because it just allows me to abbreviate and talk about exceptions at the same time. So that. Okay, so what are we going to get? We're going to create a connection from a provider and we're going to get back a connection. Oh, well, that seems reasonable. What have we done here? We've taken connection, which we know we're getting back, and we've added the word create. Try this on your code bases. Go through and look how often the word create appears. I mean, it might satisfy some basic God complex that we all have. I'm not sure. Create connection. What are we really saying? What's happened is that by using these concatenative, these agglutinative naming approaches, we actually deny ourselves the opportunity of coming up with a good name. This is where the habit gets in the way of, what's the real idea? What are we trying to do? Are we trying to create a connection, or are we trying to connect to something? Oh, connect to. Somehow, when I write that out as .connect to provider, that reads really well. And I get back a connection. Well, I can see it's a connection because I assign it to a variable that's of type. That reads really nicely. This is this naming style is what was originally meant with object orientation. You go back to the 80s and 90s, early 90s. This is what people were talking about when they were talking about effectively using objects to create a language in which you describe your domain. This has had to undergo a resurrection under domain-driven design, but it really is this case of caring about the words. What you're trying to do is connect to something. Say that. Create connection is a sort of circumlocution. You're trying to avoid saying that you actually want to connect to something. Yes?
Aren't you just gluing words together again with the two, or is that a problem?
I've got two words that are shorter and directly describe the action. Create connection. Connect to, that is the action. Whereas what I've done is I've simply said, I'm creating an object, whereas here I've actually stated the intent. My intention is to connect to that thing over there. The byproduct of that is that. And so that's a subtle difference there. It's the intention I'm capturing. It's very rarely my desire to create a connection. What I really want to do in the code is connect to that thing over there. Yeah? And so it's that, and sometimes, in this case, it happens to be shorter. Sometimes it may actually be longer, the words that you're after. But they carry meaning. That's the idea, is we want to increase our use of meaning. Often that means it gets shorter, sometimes it gets longer, but on average it'll get shorter. Now there's something else here I've done here, which is a heresy that will have me hounded out of this building. What's the other thing I did? I took the word exception off the end of an exception class. Clutches pearls. Can you do that? Is that allowed? Surely the compiler will reject that. I mean, and I'm running Visual Studio 2013, that's not going to do Java, but if I did that in .NET, given I'm now logged into Microsoft, maybe they'll report it automatically. And I'll be blocked or something like that. It's just like, I might as well be nailing things to church doors, 95 things about how not to name your code. But it only occurred to me relatively recently, I said, why do I keep putting exception on the end of this? And I had somebody say, well, that's how you know it's an exception. Well, the fact that it's in a throws clause is a bit of a giveaway, I have to admit. How else might I know it's an exception? that it appears in a throws statement, that it appears in a catch statement, that it derives from an exception type. Damn, you know, I still don't know. It could go either way. The name and the context, they tell you everything. And sometimes people sort of, well, you want to know that it's an exception. What, should I put class on the end of everything else? And maybe call my enum types enum, just in case. And maybe put interface rather than just anything else. Let's just really sort of help people out here. I saw one code base where they put value object after every single value object type, which, you know, if you're being paid by the character, it's splendid practice, but it's just the noise level in the code was enormous. It's a little bit like going through a sentence and adding the word noun, adjective, preposition to everything that you say, just to make it clearer. Connection failure. I wonder if that's an exception. Let's look at the words. Connection failure. No, it sounds like a value object. No, of course it's you know, the very clue there. And in fact, there's something else here as well. I have no problem with calling the root exception because that's what it is. But everything derived from it, you don't just add the names and keep Lego naming. But sometimes it deprives us of the opportunity of coming up with a good name. And sometimes the name is quite good. So in Java, if you want to signal that an argument is wrong, an argument to a method, you throw illegal argument exception. Let's take the word exception off the end of that. Do we lose anything? No, not at all. Illegal argument states perfectly clearly exactly what the problem is. You have an illegal argument. There's no noise words. By the way, in case you're wondering, this is an exception. Illegal argument. What's the equivalent in the .NET framework? .NET framework normally is quite good on some of its naming things, but this is a blip. What's the equivalent to illegal argument exception? Argument exception. Let's take exception off that. Argument. Okay, outside. Oh, wrong kind of argument. That's not a very helpful word. That doesn't tell you anything about it. There's something missing. Oh, yeah. So in other words, it reminds you that even if you hadn't figured it out, argument exception is a sucky name. Yes?
I was going to say that you have to kind of want something in that your code ultimately is no longer going to tell you, like if I just look for exception, for example, in a lot of items, you get a list of all the exceptions, and it's quite quick to go between. If you're in a project with like a lot of custom exceptions you're working on, you don't really want to have to go and delve into connection, failure, legal arguments, etc.
Yeah. I understand what you're saying, but I'm going to say that actually what you've uncovered there is a symptom. And I tend to look at that as a symptom. The number of times that people will tell me, we're doing this for the code completion, I'm going to suggest something really, really dangerous. It's not like driving without your seatbelt. Try writing without code completion for a day. It's radical. It starts telling you things about your code that you weren't aware of. The fact that we rely on that, an IDE is perfectly capable of giving you all of the classes descended from exception. That's what we want. We don't want the textual completion. What we want is something else. If we have so many different types of exception, then actually that's telling us, if we're not able to navigate them, that's telling us something else again. So I tend to use that as a sensing clue that the real problem is not that we've not got exception there. If that's my issue, throws, whatever, why am I not doing that for other types? So in other words, it's an inconsistency in the habit. I'm doing it for one group of things, but not the others. Why do these guys get favored and not those? So again, it leaves me with more questions than answers. So although I appreciate that what you're saying is there's a certain element of truth to it, I'm going to say that if you dig deeper, it's probably telling you something else.
I agree with you in the real world scenario, but I think that having an exception on the end is not actually.
Okay, I'm going to throw that one out there. I'm not going to argue the point, but I do want to just sort of say it's worth thinking. It's worth thinking about revisiting from another angle, because it may be the first time you've had the assumption questioned. The first time that happens, I remember sitting there thinking like, maybe not. And then I started trying other stuff, and it's just like, wow, this is really radical.
When you said it was not a case of giving you a right perception, was that statement of something that could conceptually do? Was that actually exist?
Yeah, I can ask something for all the derived classes. That capability exists within an IDE's database. You can ask for the class hierarchy. Yeah. And if it's depriving you of that, especially if it's an open source thing, you can harass them. Yes?
In one framework, there is something called as dimension or
Yes.
They tend to follow names, like, for example, in MVC, controller or use or something like that. How you are going to handle that sort of scenario? Then you
Don't use sucky frameworks. There you go, that was done. I think somebody else gave a talk on that. That was easy. No, I'm not saying that all naming conventions are bad with regularity, but quite frankly, when somebody, let's understand the problem. If you're using an MVC framework in a statically typed language and you have to follow a naming convention, then you need to take the red pill. Because you have a statically typed language, you need to use a wonderful feature called metadata. In other words, people that are writing based on naming conventions need to understand that these languages have attributes and annotations in them. That's how you're supposed to do this. So in other words...
It's not just one company with one framework.
Yeah.
Like a trend, basically.
Oh, yeah. Loads of people are doing the wrong thing. Yeah, I know. I'm going again. I am the salmon swimming upstream. But the point is, if we consider ourselves even remotely rational, we're going to do everything that all those guys who are doing bad code do. This is the problem. I spend a lot of time teaching people object orientation, and I never expected I would have to do that. I got into object orientation 25 years ago, and I thought, oh, we'll be over that, and we'll have understood it. We understand it less now than people did 20 years ago, because the habits they've done, they've created this dysfunctional ecosystem. I have no problem with using convention. Whole operating systems are built on this. The problem is when people actually don't know the programming language they're using. So when people write frameworks and they use name-based conventions for things that are just simple matters of metadata, it shows a single lack of understanding of how to code a framework. In other words, I think it's great that people explore that. I think it's great that people put it up on the web. And I also think it's great that most open source projects ultimately die. I think that's very healthy. It's Darwinian in nature. And the bad naming conventions will allow people to get past that eventually. We'll get it eventually, just not yet. But the greatest price is price. Only it's needless words. So, let's talk about something else. That's kind of relevant. Under-abstraction. The problems of under-abstraction are, I've certainly encountered code bases where people have over-abstracted, got a little excited and created all kinds of extra classes for all kinds of things. But actually, it turns out that under-abstraction is probably a greater problem, where, well, let's have a look. One of my favourite little examples is one that comes from a blog from Philippe Calsari about 5 years ago. It's a practice that I very strongly encourage people to look into. Taking a tag flag of your code base. It's an unusual idea. Take a tag flag of your code base. Yeah. Go through, this is what he did. He took the code base, stripped out the comments, stripped out the string literals, put it through Wordle, and there you get a word ranking, the most popular words. It's quite popular. This is Java based on the fact that you import keywords rather large there, turn, public, and so on. He made this case free in this particular case. What we see, what is the dominant type of the system? String. So, tell me about your system. What's it about? Somebody's hoping for a really interesting answer. It's about strings, with some lists and integers. Great. Well, that differentiates the system from all the other code systems. So, there's no meaning here. This is object-oriented assembly. We've probably got some big controllers. We've probably got some large factories. But where's the meaning? What is the code about? Have we communicated to the reader what it's about? I'm not saying that the code is wrong. It probably is correct and satisfies its requirements. But the code lacks this power of communication. As I said, you only have 3 tools. Names, punctuation, and spacing. Don't squander any of them. It turns out names are one of the most important ones. Here's another code base that we looked at. Now, I can't tell you exactly what's going on here. But I can tell you that this system has something to do with printing devices, papers, pictures, and products. Because that shines through. If we look closely, we can still see string. It's here. And we can see something else. Class is much larger in this code base than it was in this code base. Whereas class is found over there by the only identified piece of equipment hardly. Class is smaller in this one. There are more classes in this code base. Somebody has chosen to take common pieces of code that seem to be doing things like validation, stuff like that, and abstracting them into things that represent ideas. And actually that's a very common thing. It's a very simple smell when I look at the code. When I see classes that are validators. There's no such thing as a validator. What is it that you are validating? So somebody will say, oh, it's validating an address. In other words, it's an address. Address validation is a part of a concept we call address. It's not a separate concept. There is no validator. Validator is a made-up word. I'm not saying that we don't need made-up words, but it's not one of the better ones, let's put it that way. When you're talking about an address, then validating an address is part of address. It's associated with that concept. Let's put it there. Rather than we've got an address validation that's working on this string. Somebody was inspired to go ahead and do this at a games company because I've talked about this often enough that I found people do this, so this is a rather interesting one. I can't tell you the exact nature of the code, but that public is jolly large, and void is certainly pretty large. And bool, else, true, and false are huge. If you're looking for if, you won't find it because this is Word, and Wordle filters out if it's 2 letters or shorter. We have our game object and vector3 and our equivalent of strings. Really interesting. I can't tell you exactly what's going on here, but I have some really interesting questions. That's the thing, is that some of these techniques are very weird ways of looking at your code. I did one earlier on, but I didn't highlight it. One of the weird ways of looking at your code was replace all of the code with every non-punctuation character, replace it with a block or an X, and look at your code. What does it look like? Yeah. Another technique I quite like doing is zooming out the code. Put it at the smallest font that your editor allows you to look at, and see what it looks like in the air. It's really interesting. In code is complex stuff. Sometimes you just need to say, forget everything except this aspect. In this case, forget everything but the names. Let's lose everything that the code does and just focus on the names alone. And I think it's really interesting that there's bool, else, true, false. I'm going to presume if is going to be stonkingly huge. Cases coming up as big here. It makes me think perhaps this is flag-based code, flag-driven code. That's my suspicion. And this is the idea with some of these techniques, is to use them as a cue, as a suggestion, as a basis for questions. That's interesting. That's funny. I wonder why. Isaac Asimov made the observation that most scientific discoveries do not happen based on eureka moments. I've got it. I understand it. Moments of inspiration. Most scientific discoveries, and I would say the same code, are based on observations more like, that's fun, and then you pull the thread, and you follow something in. That's fun. I wonder why that is. And you can walk in with a question. I visited a company about a year ago. It was absolutely delightful. They've run many projects, large projects, but run many projects. Walking around the office, I noticed that every single project had a tag line up. It was really interesting. These guys had C# projects, C++ projects, old projects, new projects. Just walking around, you got a real sense of the differences in not only the domains that they were doing, but also the styles, the age of the systems, the technologies used, and so on. Really, really interesting. And it's much more interesting wallpaper than most pictures. So, we're talking about trying to get the domain into your code, to really think in the code. This is a nice little piece from Dan North, Code and Language Domain, 97 Things Every Programmer Should Know. Here's a very good example of something that sometimes people will think, oh, this deserves a comment. If we look at it, there are no abbreviations except real-world abbreviations. In other words, there's no program abbreviations. Portfolio IDs. ID is a real-world abbreviation, it's not a programmatic one. Portfolio ID is like trader ID, .get. Trader.get ID contains key, portfolio ID. So this is using Java collections and map of maps. I can see what everything does, but I can't tell why or what. It's a temptation for a comment, but the other temptation is a method. We can extract this. What is being said here? That's what's being said. This is actually to do with preventing insider dealing. Some traders are entitled to look at portfolios, and some portfolios and not others. That's what all the logic is. There's still a map of maps there. But again, we're focusing on the intention. What are you trying to do here? Is your goal to look up in a map of maps? Yes, that's my ambition since I was a boy. No, my goal here is to separate out, can this trader view this portfolio or not? That's the intention. So the idea here is shift your words from merely being these acts of localized Lego description to what you're really trying to say to the reader. And also look at your code from the outside. Funnily enough, recent consultancy visit with a client had exactly this problem. A very common technique is where you have two ways of doing something that are really similar, or a variation of something, is to pass in a flag and say, I want one variation or the other. When you're in the code, that all looks very sensible when you're inside the method. Because maybe this says, I have no idea what the false represents here. Gregor wrote this one, but I can't remember what the flag indicated, whether or not it's, log this, dump this file, do something else with it, I can't remember. But the chances are that that variable is probably quite well named, and none of this is, these are all in parser, process nodes, yeah, this is all good, I have no problem with this. So, the problem is from the outside. From the outside, it doesn't look good. The more extreme example was a company that I visited a few years ago. I remember we were looking at a method, 5 arguments, all of which were bool. It turns out from the inside, it looks okay. Everything is well named. Is enabled, can log, has such and such, and you can see it is enabled. Yeah, it read very well on the inside. When you looked at it from the outside, true, true, false, false, true. What? How is that different from true, false, false? What am I getting for my money here? It just feels like mindless. One of the reasons that I think there's a nice byproduct of a test-driven approach is that you are forced into using your own code. Very quickly you find out, what, that test isn't looking so good. So I'm calling this true, true, false, false, true, and I don't know what that means. So the idea here is that there are two variations and they are named. Either name them differently, process node one or process node another. But the code will be shared. Yep, that's what private methods are invented for. Yeah? So don't push that decision out on the call. Or choose a more meaningful name structure, such as an email or something like that. But there are lots of ways of solving this. But don't push it out. Don't push the convenience of how to use less code on the inside. So be very careful with this. Alan Perlis was he's the first recipient of Turing Awards, and in his programming programs, 30 years ago, he made this observation. You have received 10 parameters, you missed some. Now, he's not saying you missed some of the core. What he's saying is that statistically, 10 is as good as 11. So if it's 10 today, what's it going to be tomorrow? Yeah? If I've got something that takes 2 arguments, it's probably going to continue taking 2 arguments. If I've got something taking 10 arguments, well, it can take 14 before you know it. Because statistically speaking, they're not the same relationship. So, you can see this actually. So, what are we saying? We're saying that when you have 10 parameters, the chances are that there is an abstraction missing. Some of those parameters probably go together. They probably relate to things. They probably combine in a particular way. If I have 3 integers that represent the year, month, and day, then we'll call that a date. So instead of having 3 integers, I should have a thing called a date. Now, I would still be passing 3 integers into that, but conceptually there is one idea, a date. And I've chosen to identify that. A time code, a measurement, a coordinate. There are all these things that are together. And when things go together, they're a thing. But thing, you don't get paid for saying thing, you get paid for saying object. That's a slightly more technical term. A friend of mine actually, he used to work at IBM. He actually got taken aside during a consultancy visit because the client wanted him to use more technical language. Because Ian was talking about, these objects, they're just things doing stuff on other things. Could you use more technical language? You could prepare quite a lot for this. Objects can be methods. Maybe use the word service occasionally. Or maybe use entity instead of objects, because it's a little more okay. But ultimately, it's things just doing stuff. And when things come around together, if you've got your arguments grouped in a particular way, if you find, and again, this is a clue, a sensing clue, if you find that you are grouping arguments together when you call them, or grouping them, then that's probably a thing. It took me years to realize that. It's just like, these things are together. I should identify them as together and give them a name. Now, the name may not be immediately obvious, but at least if there's a request, could you give me a name? That's what code is trying to tell you. It's kind of whispery. The The most extreme example, well, I've used this quote with a company when I kept looking at their arguments, their constructors with 14 or 15 arguments. They were unmoved by this first quote, and I eventually understood why when one of them pulled up a method with 70 arguments. Well, actually, I still to this day don't know if it was 70. It certainly covered 70 lines. But that's been beaten. I've mentioned this on a couple of training courses since. One company, they said, yeah, it's 150. They want the best word. I think it's best in the sense of word. A company I know had a case with a piece of code. 325 arguments. And I got an email from the guy a few weeks later with the JPEG of the diff as it had in the 326th. He said, this is the latest code, this is a nightmare. But that 326, I don't know how to do that. I mean, I'm always tempted to make it up to 365, so at least there's one for every day of the year. Because that's how long it's going to take to call this damn thing correctly. Yeah, it's Thursday now. What do you plan to do over the next few days, Kevin? It's kind of scrum stand-up meetings. Okay, so, what are you hoping to do by tomorrow? Well, I'm hoping to make a good start on call now. Do you have any kind of sense of when you'll be done? Well, at the moment, I'm still thinking April, but it could slip into May. It's insane. It's a failure, a fundamental failure of abstraction. Of course, it doesn't happen by evil or stupidity. It happens one argument at a time. That's how we don't notice it, or when you focus it. Okay, that's the only single that's ever good for your code. And that's my point. Unencapsulated state. Loads of stuff. So, there's loads of examples. I mean, it's worth keeping in mind what we mean by encapsulation. A close-up in or is it encapsulated? Express the essential feature of something. So simply, funnily enough, this is actually the same meaning we normally find the word abstraction. It's express the essential feature, the essence of it. Abstract away the things that do not apply to its essence. The next one is to do with computers, and therefore is not relevant. Third one, provide an interface or piece of software to allow simplified access to the user. That's what encapsulation is about. A lot of people think encapsulation is to do with making data private. Not so much. That's a side effect of encapsulation. It's a consequence of encapsulation. It's a predictable consequence, but it's worth understanding the motivation. That's the motivation. Simplify access to the user. This is something that we find in usability design. There's a term called affordance. How the uses that something affords, the behaviours that it affords. How can we use this thing? Okay. This glass has the affordance of holding fluid, preferably cold. And I can drink from it fairly easily. It's the right size, it's the right weight, it's got a certain mass. It's just a little bit, it affords a couple of other things. It's just a little bit too small to afford holding pens. Centre of gravity is not the right position. If it were a mug, it would probably be about right, slightly taller. So it doesn't really afford that use as well. It's probably quite good for rubber bands and paper clips. I can't remember the last time I used a paper clip. It's also useful as a weapon. Two ways, actually. I can use it as a projectile, or I can smash it and use it as a blade. I don't propose to do so. These are clearly unwanted affordances. It affords these uses, but they're not the ones that we encourage. So any design thing should afford its principal usage easily. And it may have other affordances, and you're hoping that those are not going to be too bad or too frequent. But that is what encapsulation is about, trying to make the principal thing affording simple usage. The idea that common easy use, the common use should be easy, and other things may be possible. And some will be accidentally good, and some will be accidentally not so good. So I mentioned the use of users earlier on. Here's a very common smell in the code. I've come to think of it properly as a smell. I've chosen to make the properties explicit here, but what we've got here is a list, and I'm using a list internally, and then I've got a property here called items that will return the list there. This is very common, this approach. You go to an object and you say, you either have a getter or you have a property getter to make the syntax less offensive somehow. Here, have this, don't worry, you can use it, it's okay, it makes it easy for you to access. And it all looks like we are doing the right thing. The emphasis here, the reason I'm using explicit rather than auto properties, it's private. I've said it's private. That list is private. Nobody can touch it, except when I give it away. And people will say, well, that makes it easy. Look, I've saved myself code. Look, I've only had to provide an add method. Add a string. If the string is null, throw an exception. Otherwise, remove any duplicate occurrence and insert it at the head. And I haven't had to write a count property. I haven't had to write any other properties because I can get to those via list. Yeah, it's true. I can go and take that. I can go and add hello world, and then I can go and get the count, which turns out to be 1. Then I can go and add hello world again, but bypassing the add that you should be using and using a different add. In other words, I've just gone and added a second occurrence to something that is supposed to be a set. When I ask for the count, it will be 2. This should be impossible, because a recently used list does not hold duplicates. The duplicate insertion moves to the head. But apparently I bypassed that. And even better, I can choose to insert null, which I've just said expressly no. So in other words, a recently used list is a list that holds non-duplicate, non-null items. And what have I got? Duplicates and nulls, and I didn't even have to use reflection. It's just, so what are we talking about here? What we're talking about here is 1980s vampire movies, before paranormal romance became an exciting market. Wonderful film, or at least my memory of it is. I don't want to watch it again because my memory is intact. I liked it as it was. I've been disappointed by rewatching a couple of things from the 80s recently, and I'm not going to do it again. Especially when you're watching it with a savvy teenager. Damn, so old. So, but it does have some memorable lines. One of them is, don't ever invite a vampire to your house, you silly boy. It renders you powerless. This is the essence of encapsulation. It's not just a private keyword. Have I made it easy to use? And when I'm talking private, have I really kept it private? Or am I just giving away, am I inviting the vampire in? And I say, have the underlying collections. Do with them what you will. Bite me. We see here, for example, I've got an implementation that inserts at the beginning and indexes forward. But I can easily switch that to append at the back and count backwards. These are equivalent implementations, but only if you keep the representation private. Strictly private. So there's a couple of other bits and pieces that are worth covering. In the interest of lunch, actually, in the interest of lunch, let's talk about guesses. I said I was in this language. I have a copy of the OED. Yeah. Oxford English Dictionary is not a prescriptive dictionary. It holds entries that it talks about in English language going back over 1,000 years. It gives you full etymology. So if you're a word geek, this is great. If you're actually looking for a simple usage guide, don't get this. But what is interesting is the word get. Sometimes people use the word get. They're trying to disambiguate something. I'm trying to make it clearer. By putting the word get in, I'm going to make this clear. Get, it turns out, is a word that has the most definitions in the English language. If you look up here, you can see that there are multiple entry points, and the scroll bars, I would like to point out, are proportionate to the size. If you print this out, if you actually get a printed copy of the OED, I'm not even sure if they're going to do that in the next edition, get covers about 30 pages. So yeah, very clear. When you call get, does it have a side effect or not? Because that's the big question I always have whenever I see a getter. When you use something named get, does it make it clearer or not? If I get married, that's a big side effect. If I get cash in a cash machine, that's a big side effect. If I get my age, then I look slightly bewildered and wonder if I can fit it into a minute. But the point that doesn't have a side effect. The point is that we have the one thing that actually matters we haven't communicated to the reader. The one thing, there's only one thing that matters in something that returns. an object or a value? Did it change something, or is it a pure question? The one thing we could have communicated, we have squandered, because that word doesn't say it. If in case you're wondering, which I'm sure you were, what is the word with the second most definitions in the English language? Well, that was set. Now, I'm not saying never ever use these, but do question your use of things. Sometimes people put these together because they think of get and set as opposites. The opposite of set is not get, it's reset or unset. In fact, I'm delighted to discover how old unset is. It actually dates back to Anglo-Saxon times. Unset. Great word. Feel free to use this in your code. But what we're saying is that part of this is linguistic, but actually the real issue here is not the fact I don't just, it's not a personal preference against all of these get and set. It's the fact that we're not communicating what we mean and we've got a habit. When people see a get and then we put a set, it's almost instinctive, they can't help themselves. In fact, there are a lot of shortcuts and generators that will do that for you. You can do the wrong thing faster. We need to be very careful with this. In many cases, what we're trying to do is query something. And if you are querying something, you have to ask the question, do I want to be able to change it as well? It turns out in most cases, you would like to avoid changing it. Not every get should be partnered by a set, whether it's a property, or a named method called get, or a named method that queries but is not called get. It doesn't necessarily have to have a counterpart. There's a very common style where you write fields, and then you write a get, and then you write a set. So automatic, people don't even notice they're doing it. So, a simple little example, yeah, try and do this. Write a day class, get month, set month. Then you realise that there's actually more to life than this. So you add in everything, it doubles the size of the interface. And then you realise you can get the same functionality just by doing something else. Focusing on immutability. Restrict the mutability of state in your code. Feel free to put the gets in, or actually, not. But the idea is that the real downside of the get set habit is not the get, it's the set. This problem is made quite visible in the context of threading. I cannot read this tweet out because I have no idea how to pronounce the last line, so I will leave it to you. When you are working in a programming language that shares state through the use of references, you already have the problem of aliasing. All threading does is just turn the heat up. All the problems you had before get multiplied. It's an amplifier. And it turns out that people have a lot of threading problems. And I always wonder why. Because it turns out there's a really, really simple way of writing thread-safe code. And there's a quadrant diagram, so it's managed mapping. Your state is either mutable or immutable, shared or unshared. It turns out that there are three places where this all works. If I have state that is modifiable and it's not shared with other objects, and therefore the access is not shared by methods, then it turns out we can know those state problems. If the state is immutable, then I can share it as much as I like because it's not possible to modify it in a way that causes problems. If it's both, then I have the best encapsulation possible. So in other words, if you want to write thread-safe code, avoid the red corner, the bit that says shared mutable data. There's a lot of people sort of think, oh, we have these threading problems, or our architecture is based on this, or you don't want to do that. Well, it's based on that, yeah, but that doesn't mean, just because it's based on that doesn't mean you want to do it. This is the quadrant of pain. It's very, very simple. And it starts with getting rid of the sets. Okay, so final thing to wrap up is the question of uncohesive tests. Now, I spent a bit of time talking about this yesterday, so I'm going to go very light on this. It's good that people now get to have a testing. I think it's a great thing. But there is something in the vocabulary of test-driven development that is often overlooked. Everybody knows that TDD stands for test-driven development. However, people too often concentrate on the words test and development and don't consider what the word driven really implies. I love this quote. It's from a blurb for a conference session from a few years ago by NAPRICE and Steve Freeman. They really talk about what is the meaning of this term driven? What are we expecting? And they're not just talking about the mechanics of the test-first approach. That's not what they're saying here. For test to drive the development, then it's doing more than just test the code performance as required functionality. And it's clearly expressed required functionality to the reader. That's very different. It goes back to what I was saying earlier. Normally, what you find is people, when you say, you're testing the code, okay, that's good. Why are you testing the code? I'm testing it so to check that it's correct. Okay. It turns out that's not the hard problem. The hard problem is, what do you mean by the term correct? In other words, what's it supposed to do? Because the test could pass, and I still have no idea what the code does. Because the tests don't explain it to me. They don't have strong explanatory power. They simply have a mechanical, I do this, I do that, something happens, it passes, it's great. But how do I know what it's doing? And that matters, because one of the pain points people have when they introduce unit tests is the maintenance of the unit tests. If they go back to them, it's just like, I have no idea what this is doing, so therefore I don't know, in the context of new behaviour, what it should be doing differently. Because it doesn't express what it wants, it expresses mechanics. I saw a test case last week that was just like this. It took me ages to work out what was wrong, and I sort of eventually realised, I said, there's nothing wrong with the fact that you're testing stuff, but the problem is I have no idea what you are testing. And I asked them, can you tell just by looking at the code? And they said, no. But we know that it's working, whatever it is. It turns out it is the hard thing. It. What does it mean for it to work? And there is this very common habit. Go back to our friend, we should use this. Very common habit. It's obvious, intuitive, and wildly wrong, unfortunately. A very common habit of aligning our test cases one for one. I'm going to test the constructor. I'm going to test the indexer. I'm going to test the isempty property. I'm going to test count an indexer and the add method. I'm going to test each one individually. Okay, how do you test the constructor without calling something else? How do I test isempty properly or the count without being able to add? How do I test the add behavior without knowing what the indexer does so I can check everything's in the right order? In other words, these are cohesive, they're coherent, they live together. You cannot actually test an individual method. This is a myth. It took me years to realise this, but I still see code out there. It's the most common testing style. Methods A, B, C, test A, test B, test C. It's not possible. You cannot do it. If you think you have an example where you have one-to-one alignment, email me, and I will email you back why it doesn't work. Or a beer voucher, but I haven't given out any beer vouchers yet. Okay, so let's do that. So let's close with, what do we really want to do with recent use list? How would I express this? So expressed in any unit, let's get rid of the function words and the function. Let's focus on the content. What we see here is a hierarchical description. Recently used list spec. A new list is empty. An empty list contains a single addition. An empty list contains unique additions in stack order. A non-empty list is unchanged when a head item is re-added. A non-empty list moves non-head items to head when it is re-added. Any list rejects addition of null items. What I have here is a simple example where I've actually just described the behavior of the class. When those tests run, what you're left with is a manifest of its behavior. Not behavior in terms of a shopping list of methods, but in terms of a set of interactions. You like mini user stories at the level of the object. So this one makes a fundamental difference to the quality and perceived quality of what your code is doing. So notice, that's the problem. A lot of test cases are not a test case. They blur things, they scatter things around. A test case should be just that, it should be a case. What is that case? You don't have a case of add, you don't have a case of count, you don't have a case of indexing. There are multiple cases in each case, so to speak. Yeah? I can add a duplicate item, I can add a non-duplicate item. That's two cases already for add. So add is not itself a case. It has cases. And on that slightly overdue note, thank you very much. I hope that has been either thought-provoking or just provoking. Feel free to hurl general internet abuse my way. Or profoundly considered questions. I'm good with either, although I'll answer the second one and the first. And I hope that has been of some use. And it's something you can now go and digest over lunch.